at OpenAI. I work in the safety systems team. I do like two types of work. So I work with the product team in order to enable readiness and safety launches for each of the products. And the other part I work on is enabling like research engineers and ML engineers to work on ML classifiers to identify like novel risks. So the data that I basically produce, like kind of model, is used by both the teams to make different decisions. So today, we are going to see how we can move from a concept called as a data lakehouse into like a continuous learning data flywheel. Okay, so as everyone is aware, like a traditional data warehouse, you can see like there is a lot of volume that is coming from any interaction that happens with the product. This is like highly, like mostly like structured data, like event logs that comes in through. And there is a concept that where you move like from the bronze to the gold layer, for example, bronze is like a raw and silver is like more of a staging layer, and gold layers is where you have like structured and very rigid contracts like facts and dimensions. This is, as you can see, very dashboard and analytics driven. But in the current world, you can see that the raw data here has like a lot of insights. Say, for example, you're interacting with ChatGPT, the amount of text that you send is really like valuable, and it has like a lot of insights and capabilities to understand new and evolving model policies. And as you know, like earlier we cared a lot about like data audits. Like, think about like, oh, this many columns had null, and this is like a count drop that happened, and if you see like week over week, this metric is dropping. Those are very important, but we also need to move into the part of having qualitative metrics, like understand like how diverse is the data, understand the context of the conversation itself, right? Like, what is the conversation level classifier? Are they like talking about like fun events, or are they talking about like creative writing, or is this like a harmful kind of conversation, right? So there are like different use cases of how the product is being used, and this is very important to move towards like developing new products, because you want to match the user interest with the new product development. So moving on to the next slide. So this is like how a traditional data lake is. There are like events like streamed from Kafka. It is just being streamed using like some technologies like Flink, and also like Apache Spark streaming. It all like goes to the data lake, and the data lake is where like you have the raw information from into something like structured table, and then there is unstructured data available like in a file format like S3 or GCS, where we just store like the content as well as the metadata information. From the structured table, you can see that there is a lot that goes into it, like metrics, like you can create your own like eval data warehouse and also training and so on. So this is how it used to be, right? Whenever people wanted to access the data, they just used to do like normal SQL querying. And if they want like some similarity in the raw text, like they want to find like how many conversation match like a certain kind of a criteria, like as I was mentioning, or whether it's like you know I want to explore like creative writing prompts, like how people have used the application. You need to connect like a vector database and kind of understand like how these conversations are similar and so on. So it used to be like a separate thing. And if you want to do like a full text search, you need to enable like elastic search and so on. But in the modern world, we want to enable everything in the data warehouse itself. So I have linked like two concepts here, like which folks can take a look whenever they want to. But the core concept is the same, is where we maintain everything in the data warehouse. And this data warehouse enables everything, like basically SQL, semantic search, indexing, vector search, and so on. So there are like some technologies that do this. Like there is something called as LanceDB, which does this, and also like RocksetDB, which you can actually use this as your data warehouse. But also, with the same like SQL query, you'll be able to understand like the dot product, or like the cosine similarity between like two different um, text format. Like say for example, you want like show me the videos which are similar in frames to this one, or you want to say like, oh, let's see what are like the relevant examples or the past tickets that look similar to this incident, something like that, right? Like these are all like, you want to make sure you provide the context in the natural language, and the data warehouse is able to understand and provide you the the resultant text set. And also feel free to stop me like if there are any questions. But yeah, moving on to the next slide. So here we want to understand like what is data flywheel and why do we need it, right? So as we know, like anytime a user interacts, there is a lot of logs that get generated. Some of them are structured logs and some of them are unstructured. So what I mean by unstructured is you keep interacting with ChatGPT, it generates like so much amount of text in a conversation. So how do we understand that in a privacy friendly way, right? So there is a lot that goes through this. So, say for example, there is a lot of PII information which is redacted, and also on the fly, the user ID is encrypted, and they are moved to specific like training zones, right? And if you look into the other aspect of these logs, I have mentioned that these move into like synthetic data generation and human feedback. A note is like every data log does not make it to this phase, right? It's really impossible to get all the information from the logs the user are generating. So there's some kind of sampling technique where we want to understand like a random slice for a broad coverage of use cases, or a targeted slice from error use cases, or anything that like we are seeing in the social media that folks are reporting. So this helps to keep the cost like manageable and avoids like over representation of a particular use case, and so on. So here human feedback is a place where we still take some seeded examples from the logs which are like problematic, and kind of send them for human labeling, like say for reviewers and analysts, for them to make a decision on that particular record. Say that this is unsafe, fraudulent, this is kind of a prompt injection thing that is going on. So these corrections and these labels is what like makes it to our data warehouse itself. So also this each of this boxes that I've added is a whole new presentation in itself, because for human feedback there are many things like how we assess the feedback quality, inter-rater agreement, and so on, but I will not go more into that. The next part is like the synthetic data generation. Say for example, there is a new model policy and different failure modes that the model policy team comes to you with. How do you actually get the data for those, or how do you test if your model like kind of performs well for those scenarios, right? It's very hard because you really cannot find those use cases in your natural traffic. It's very rare. I wouldn't say you will not be able to find, but it's very rare or risky, because like some of them like they are completely like PII redacted, and some of the content are also like little bit like we add like a lot of things to change the email or something like that, so that like we can make sure that these are not like retraced back to the user ID. So that's when synthetic data generation comes up.
Can you
Oh,
give an
yeah.
example maybe of like a policy, like what um I believe, if I understand correctly, you get a policy of like this policy needed to
Mhm.
you need like uh, um, to force kind of those like this policy or this PII. So like if you can give an example, how does it look like what the outcome that like uh, that they want to achieve, and maybe how do you force it, and how do you make sure that you actually apply to that policy?
Okay, so the one that you are saying is like a rule-based engine, right? Like there are classifiers, there are also like rule-based engine where we definitely don't want the model to even answer with respect to that. So, say for example, when I was at Twitter, they were like I was at Twitter, by the way, before like Google, and there was a lot of issue with respect to elections, like where anybody like posted anything with respect to elections, it would just like block the tweet, right? So that is like a rule based engine. Basically it never goes to the it goes to the ML classifier to tag that content saying that it's related to the elections, and then it would just block it without even like reading the content. So there are other policies, like say for example, you are training like a self harm classifier, right? You want to make sure that like if the prompt or the generation is inciting like self harm, there are like different failure modes that the model policy expert comes up with. And then one such example is you can go into a number of like open source data sets which have like a proper license to kind of understand like what are the data seeds that can be used for this model policy, right? And also the model policy itself like work with experts to come up with this seed, and based on that seed we you can pass it through like a generator to kind of generate very similar examples. So this kind of helps to like train the model, and at least the model would be aware of different similar use cases, right, that can happen in reality, but it does not happen that prevalent so far in production. So yeah, did that answer your question?
Yeah, thank you.
Okay. And what are like some of the logging principles for this, right? So the main thing is being schema first, being really aware of the stable contracts. So what I mean by this is anytime an event is generated, there are multiple ways you can define the schema first. At Google, we used to follow a protobuf where the event is going to define a protobuf. And in multiple other companies we use a format called as avro, where we are aware of what fields are going to be recorded and what needs to be encrypted and so on. And the main thing that I was also mentioning is privacy and safety first. So they're usually like for certain teams, like for safety teams to investigate, or like sometimes there is a workflow where it goes through a human reviewer in case it triggers like very high safety issues, right? So for those parts alone, you can store like the content like for a certain period of time, say like you retain it for 15 days or retain it for 60 days, which actually needs to come from the legal team, and it depends upon which geographical location you are in. Because if you go into Europe, there is a lot of like GDPR guidelines which we have to follow, but in different countries it depends how much you want to store the data or where you want to store the data, like in specialized like decentralized zones which are only being used by human reviewers and so on. And yeah, so moving on to the next slide. Okay, so again, like I just want to reiterate the fact that why do we need synthetic data and how can the Lakehouse support? So in all of these, you must have observed like a common theme that uh, I'm not going like more into the detail of each of it, like synthetic data, human feedback, and so on. But I just want to reiterate the fact that how a data lakehouse can power these use cases for model retraining, post-training, and so on. So yeah, to reiterate that why do we need synthetic data? There are like very high amounts of adversarial patterns that are noted in social media. You must be aware, like when ChatGPT released like the Atlas browser, some people like they go into the phase of like jailbreaking it and find out like certain patterns that can provide like some signal where we don't have this data in natural traffic, but it's kind of very rare. And if there is an attacker who spams a specific pattern, we want to bake those scenarios to test the behavior in real world. And as I mentioned, like model policies or new emerging risks, that's one way, one place where we want to generate synthetic data. And the main point that we want to understand is it's supplemental and it can never replace user data. So say, how can a data lake house support this feature, right? So as we understood, everything needs to be tagged. We want to make sure for which synthetic policy this particular data set was used, which adversarial suite did this particular data set address. So we want to make sure it's versioned, governed, and reproducible in the data lake. So for each scenario, you want to make sure you tag these. And also, like for the creation of data seeds, it's kind of always requires a human in review, right? Like you need someone to create the initial data seeds for you, and then you have like a particular generator that creates like a list of these synthetic data sets. So you also want to tag like which generator you used, because that's particularly like very important, because we want to deterministically regenerate those particular synthetic suites and kind of make sure that we are labeling them accordingly for training or for evaluation. Um, so that would guarantee that every model that you test is going to perform the same against the same set of data. So moving on. Okay, so data ablation is another concept, which it's very popular in the model building world, where model ablation is very much heard of, where you remove like certain layers of the model and you want to see how it performs and so on. So data ablation is basically the same. You want to remove like certain parts of the data sets and make sure that did your model improve or not. Say for example, you are creating like some features involving user history or like session level behavior. You want to make sure that your area under curve improved or decreased, right? We want to make sure that the product versus infra trade-off happens in a way like you want to understand that if the drift is just like 0.1%, does it make sense to include this feature because it's very compute intensive. So those kind of decisions is what you can make with the data ablation study. I've seen like in a lot of companies, like this is maintained like in CSV sheets and in like Excel sheets, which I'm not a big fan of, because we want to make sure that this is completely like able to be recomputed and reproducible. Uh, so one other thing that I want to mention is there's something called as the chain of thought leakage as well. So if you think about a particular scenario, like nowadays, every model has like the reasoning capability. It has like a chain of thought, right? And then it answers like the question. A concrete example is like, for example, you're using the LLM itself as a judge of a prompt, right? You want to say, oh, can you tell me if this is inciting like violence, something like that. You pass that through the LLM itself. You want to make sure that you don't provide the chain of thought as an input feature, right? When you're training the classifier. The reason why you don't want to do that is think about a way that is your classifier really judging the prompt, or is it getting the chain of thought from your input feature and just like saying this is right or wrong. So those kind of scenarios you can test out with your data ablation. It's just like a phase where we want to make sure that we are not retraining or post training like blindly. We want to make sure that the lakehouse is used to run like these control experiments on the data sets itself. So how can the data lakehouse support, right? So since I mentioned, you want to make sure, okay, adding this feature, how would my model perform? Removing it, how would it perform? And you want to say like, I don't want to run with this particular, like say you have like 10, 15 data sets, but you say, oh, I don't want to run with this data set. So there are like multiple configurations or model policies that you have here, which is highly manual, and it's being like tracked in like say like an Excel or a CSV format. So how can you modularize this is you can recompute this under like different configuration using Spark, DBT, or even like Apache Ray. Ray is very popular for this. And this can be wired into a lakehouse where you can parameterize this like for different use cases. So you can also name, so I've also given an example, like say you want to say base v5, and this is like an ablation result by removing device and applying like a different window. So this helps to maintain like the data set versions and lineage for you. And it's as you may understand, this is very reusable and it helps with the auditability. When these feature groups that they get like super fragile, like as your company grows, there might be like a lot of feature groups that you want to include or remove. It's very important, like for some domains like finance and health, you want to audit what you did with the data. So this is really useful for those use cases as well. um, yeah. So moving on into like anti patterns, like what you don't want to do with this retraining, right? You always want to make sure that you have a clear do not retrain policy. Like say you want to have a policy where you want to say that you don't want to retrain if the performance of safety metrics on protected groups or something has dropped, or like data quality checks fail, it's highly unbalanced, those kind of things. You want to make sure you have like a proper do not retrain policy. And as you know, like teams run like a lot of A/B tests, and the logs actually don't record like which variant actually produced that output. So again, like there are teams which scramble, they want to go back, they want to track things manually, and we really don't know, okay, which model generated this error or which policy version was active. If you have worked in a kind of a startup culture, you might know that these policy version keep updating like every day. So you want to make sure that you are capturing everything in your lake house. So always you might imagine you need to have like model ID, policy ID, experiment ID, which are all like the metadata tables that we understood. And also with these large blobs of data, we need to like in a real like um, high volume data space, if you do like a select star from a table, the results would not even show up. It would say that the results are too large, like say limit 10. Even if you add limit 10 or limit 1, it wouldn't work. Because say you're storing data at like the conversation level, some people have like 1,000 messages in their conversation or even more. Like if you know, you can also share your conversation with other people and you can restart the conversation. So it keeps like so if you're doing it at the conversation level, like group by conversation, you see like 2,000, 3,000 message blobs, right? It's so hard. Like sometimes you need to add like some truncation logic, or catch these kind of high volume data messages, try to truncate it and then like commit. So in that way you are still preserving the nature of the conversation, but we are not like breaking anything back end. And the other concept I wanted to share, it's not like very relevant in this kind of text world. But if you look at like when I worked at Google prior to this, I worked in the ads planning team within YouTube. So we used to share like viewership metrics to third party partners like Nielsen, Comscore, and so on. For those kind of use cases, there is something called as differential privacy, where we add like a little bit amount of noise to the aggregated data, so that like it's not re-identified back to the group. So what I mean by that is, say for example, you are in a country where there is not like a lot of internet, right? Very few people get access to internet. So when you're aggregating data, say within 40 to 50 years old, these are the number of unique reach population that we reached, and these are like the total watch time for that particular demographic group. It is easy to retrace back to those who have access to internet, because this might really, you might know who that is, right? Because most of the folks, like 80% of the folks, don't have access to internet, and only 20% of the group have access to internet. So you kind of can know who has been watching YouTube. So there is a concept called as differential privacy, where you can apply like noise to the data so that it's not like easily retraced back to that particular demographic group or to the level that you're aggregating and so on. um, yeah, as usual, like it's very important that we have like a proper retention policy, like say for raw logs, retain it for 15 days and then like kind of remove PII and retain it for more time, so which is pretty common. And also the SLA for structured insights. Sometimes like we see like the downstream pipelines keep running for 14 hours, 15 hours, like for the main reason that I described below, like the conversation level, right? You want conversation level metrics and it just like breaks. So it's very important like you skip those kind of messages or have like a proper truncation logic in order to meet your SLA. um, Moving on. So I just want to provide like I hope this is visible. Is this slide visible? Okay. Yeah. So this is just like an end-to-end flow. Say you want to build like a real world like ML classifier. What are like some of the steps that you need to take, right? This is I'm talking about this from a data engineer perspective. So here you capture all the production logs, events, outputs, and so on. And then you build these curated features and raw labels. And obviously you do have like the raw data, like as I presented in the second slide, where you have everything, right? Like in even in the unstructured format. Let's come to the human feedback a little bit like later, but let's go into the data detection and data gaps. So here you can see, like as I mentioned, we just think about, oh, how many nulls are there and if there is a drop in the metric and so on. But more than that, in the face of big data and having like unstructured data, it's very important. We have like a lot of qualitative kind of data quality. Say like how many segments are present, how many conversation belong to a certain kind of a classified group, what kind of demographic groups are using the model in a certain way. So these are like some of the things which need to happen in the detection and data gap phase. So in the real world production classifier, you can see that we just don't have some labels. We also want to make sure we have like a human feedback loop as a part of this, which which can happen in the middle, but it usually happens after these data gaps, right? You want to make sure which data gaps are missing and make sure that those are captured in this phase. Um, okay. So moving on to the rest of the diagram. So I'm sorry, it's a little bit hard to read, so I just wanna, yeah. So from the curated tables that I mentioned, you have like human feedback, you have like the golden set, and I also want to make sure like what is a golden set. Say the same set of data is being graded or being reviewed by 2 to 3 kind of experts. You want to measure certain things like inter-rater agreement, how accurate they are. You can also use LLM to make sure that you know whatever they are saying is agreeing with that or not, and make a decision based on that. But this golden data set is where we have like the most trusted set of labels. And so in a real world, we also want to make sure we have like this semantic layer that I was talking about in the second slide. We want to make sure that we have like a micro batch pipeline which builds these embedding jobs using the embeddings, any kind of embeddings, which can be word to vector or BERT. And these embedding jobs need to happen at like a micro batch level, so that we are able to understand like the data drift, right? Like we want to understand, okay, this vector might be different from this and so on. So this semantic layer takes care of that. And going into the phase of how you want to select and train. So there are different type of like sampling techniques here, which I will not go very deep into because the data scientists are an expert at that. Like they have like kind of like stratified sampling, logistic regression sampling, and so on. But as we noted in the first slide, we will not like train all the data. We will apply like some kind of sampling to the data to select certain kind of examples and make sure it is completely like balanced by using synthetic data to augment those kind of use cases. And again, that synthetic data has to be labeled by these humans. So it's like a loop that happens, which with the previous slide here. So let me go back to the previous. Yeah. So this is a loop that happens here. And once the labeling, sampling, and the semantic layer is done, the final phase is where you train the model based on all this data. And this is a loop where, as you can see again, like we go into the phase of data detection. We detect the drift, we detect like what kind of categories are not present, what failure modes are absent, and then keep this as a loop. So this is just like an example that I wanted to share. And yeah, please let me know if you have any questions. I think this brings us to the end of the presentation.
Th- Thank you so much. Can you share more of the um, what should we be aware of, like kind of good versus bad approaches, things that you have tried that failed before you go to that kind of architecture?
So the things that have failed, that's a great question. So as I mentioned, like a lot of these, it depends upon like the grain that we want to, uh, have the data at. So most of the classifiers, like which we have seen, if you are doing it at the message level, what I mean by message is like, okay, you send a message, then there is another message, the generation happens, and then there is a message. If you pass these messages at the individual level to the ML classifier, in that sense, if you see, it's not like very harmful, right? But if you look at like the context of the entire conversation, it might be really harmful or toxic. And if you look at the user level, like say you want to sample like some stratified sampling of the top 100 conversations and then pass it to the classifier, it might sound like really toxic. So it's very important to understand at what level we want to grade these outputs. So the data lakehouse needs to support that kind of grain. uh, and it's like really complex because as you can see at the conversation level, your pipeline just like breaks, and it's like a lot of compute, right? So it we need to make sure we work with the model policy experts, the data leads, the ML engineers, to make sure we have the infra and the support to train the classifiers at the correct level. Yeah. I see another question.
Yeah. Hi, Swetha. This is Shilpa. I heard you say that you've been actually, first of all, can you hear me?
Yeah, I can.
Okay. Yeah, really interesting presentation. I heard you say that you've worked at a few different companies like Google and Google Ads and now at OpenAI. I'm curious, this question is more high level. So I'm curious, kind of, those are fairly different use cases, right? So as you've been a data engineer at Google Ads and then OpenAI very specifically, what have been some of the differences in how you manage data that you kind of had to adapt to? What's different about working mainly with LLMs versus something like Google Ads, which is more traditional software? At least it was in the past.
Yeah. So one thing I want to mention is at Google Ads, all the data was structured. So I was working with the raw playback data that was generated from YouTube. So I mean, it did have like a video context and like frame context to it, but I really like didn't work with it. I worked on the measurement side, as I mentioned before. So it's very different. Like as I mentioned, like there is a lot of there is a lot of weightage given to to the data number itself. Like what I mean by that is, oh, the viewership dropped, the something happened with respect to the reach is modeled beyond the population in a certain country, and then we go back and kind of make sure we correct it that it's less than the population. So it's very like traditional software engineering. And when I was at Google, I did also do like a 20% with the DeepMind team. I worked in the responsible AI team. So that's when I got like a little bit exposure into, how we can use data for this retraining process itself. So that's my kind of my shift. But as you can see, like what is different is there is a lot of text data at OpenAI. We sometimes like really don't know how to understand the context of it. We use LLMs as classifiers sometimes, and there are also like traditional ML classifier that has like logistic regression, XGBoost, like very complex augmented regression sampling, which we use. It's like a big shift where we have moved more into the qualitative metrics, like understanding the context of the conversation itself, understanding like how the model policies affect this retraining loop and so on. So I feel it's a big shift from where I've been, but I did have some experience like in DeepMind and also at Twitter, where I was still in the trust and safety team over there. So I was still like in the ML classifier world. So
Yeah,
yeah,
thanks.
I hope that answered your question. Yeah.
Yeah, no, it did. Thank you. That's actually really interesting that, you had to move from, and correct me if my understanding is not correct, but very quantitative driven data at Google to more qualitative. You said you're using LLMs to kind of classify some of the data. What in your experience, how good have LLMs been at doing that?
That's a very like broad question. It depends. So it depends at what level. Like, are you using that for metrics, measurement, or are you using that for the production classifier itself? So these two are two different things, right? Like there is a separate system which we kind of send the entire conversation to a LLM labeler and make sure that if it's harmful, we send it to human review. So if you're using for that loop, LLMs have been doing just fine because we use LLMs to also translate the data in different other languages to English so that the human reviewers can kind of uh, take a look at it or flag it and so on, right? So that's that loop. But if you're trying to moderate things in OpenAI itself, if you look into the OpenAI developers page, there is also like something called as the moderations API. That is something that is a traditional ML classifier. So those both are different and for different use cases. So yeah.
Okay, yeah, thank you.
I'm curious about best practices for LLM as a judge. Like, we try different ways and use cases, and again, like how you turn it into more quantitative data than just like just to see the responses.
So it depends, right? Like you can use uh, different ways to identify like toxic content. One is LLM as a judge. You could also use like toxic BERT, which is not an LLM, but it helps you like with the vector itself saying that whether it's like toxic or not. So it's dependent. It kind of depends for which use case you're using. Say, are you using this for A/B testing? Are you using this for
I can give you an example. I worked with company that they build like Gen AI marketing automation, and one of the targets was to create a kind of personalized marketing content to like specific audience. And then somehow you need to measure, did it actually was personalized, yes, enough, or did it has the um, like the same branding message, or is it specific enough to that specific audience? So how would you target that with like LLM as a judge?
Mhm. So, in my opinion, like you don't have to like quote me on this one. At LLM as a judge is mainly like echo chamber, right? You want to make sure that it's not like mimicking the actual product or safety goals, but it at least helps to give you like a reasoning why that's unsafe or why that is factually incorrect. So it's up to it depends on the use case how you want to integrate LLM as a judge into this process. But
Mhm.
at least for me, I feel like you should never treat it as a ground truth. You should always use like embeddings like toxic BERT in order to give you the reasoning why it was toxic and so on. But it helps in use cases where it's like high recall. It is able to understand like more, even though you provided a role, right? Say that they are like this kind of role, like they are a model policy expert, and then you can ask it to judge the content. You want to make sure that you provide the role and also like the current prompting technique, but it tries to identify like high recall kind of scenarios where it just says this is toxic,
How,
but you look into
how
high
do you
that doesn't happen, right? Yeah.
how do you measure accuracy at that scale, right? You have like billions of messages that you need to classify. How do you measure the accuracy of the classifier?
So we don't go more into the accuracy. We think about recall and precision. We want to capture as many positive cases as possible, which is like high recall. We want to be really safe that even if it's like a small kind of toxic content, we still want to flag it as this is positive for negativity or violence. So that is like a recall, and precision is where you want to really tag only the positive uh, use cases, right? So that's how we that's how we measure classifier recall, precision, and also area under curve. We don't go a lot into the accuracy, because like even though if it's like highly accurate, like say for example there is only 1% of toxic content in this world, right? But your classifier can be 99% accurate, because there's only 1% of toxic content, but it was not able to catch that 1%. So we want to be as precise as possible, more than accuracy. Yeah.
Maybe I will ask it. So how do you know like that you catched like all the, let's say, the issues that you wanted to catch in the platform versus this is like based on human feedback, or do you have any other ways to like kind of measure the coverage of like how what was like the coverage of the actual toxic
Yeah.
messages that
So
you were able to capture or not?
yeah, so for each of the categories, we have something called as prevalence. We say what is the prevalence of this particular harm category that exists in this conversation. The next thing is like when a mitigation happens. So what do we mean by mitigation is, right? Like it says, okay, we cannot give you the information. That is like when a mitigation happened inside the product. That is like a residual prevalence. Like after that happens, what is the residual amount of prevalence that occurs in that category, right? So this is how we measure like if a particular level of harm, how prevalent is it in production, or where do we need to focus our eggs more into, right? So that's how we make the decision. Did that answer your
Yeah,
question?
thank you. Um, guys, feel free to ask more questions if you have. If not, we can finish a few minutes earlier. Looks like we don't have any. Thank you so much for giving that session.
Yeah, thank you so much for everyone like joining this session, and thank you, Boaz, for this opportunity.
Thank you.
Bye. Thank you.